Hello, hi everyone. So in this video we are going to see about System Verilog data types. There are few interview questions, basic interview questions about the data types. I've captured all those questions here. The following slides would give the answer for all these questions. So number one, what is the difference between logic and bit in System Verilog? What is the difference between data type logic and wire? What is the difference between byte and bit? What is the difference between bits and logic? And the difference between data type logic and reg? What is the difference between logic and the byte in System Verilog? And how does this compiler treat the 4-state and 2-state data type variables? Let's go over in the following slides and try to understand the different data types in System Verilog and how that differ from each other. So first one I have described the logic and register reg difference. Maybe a general comparison between these two data types. So logic is a four-state values 0, 1, x and z. 0, 1 we know that it's a logic 0, logic 1. X is the unknown value which is given as x. Z means the high impedance state. So that is that value can be like anywhere in between 0 and 1. That's the high impedance state. So these 4 states can be defined for the logic variable. Reg also has same like logic. It has a 4-state values 0, 1, x and high z. That's high impedance. The usage wise, if we see logic, it can be used in both procedural statement as well as the assignment statement. Procedural statement means like always inside inside the initial logic can be used. Assign also inside the assign block. But the other difference is reg can be only driven by the procedural block. It cannot work with the continuous assignment statement like the assignment statement like the assign. But it works only with the always and initial. If you look at the multi-driver, logic data type doesn't permit the multi-driver. In case there's a multi-driver, it just simply assign the last value. Whatever the last assignment value, it will just assign that for the multiple assignment. But reg data type, which will gives x in case of multiple driver. So, try to drive them with the different values, right? That's the difference between the reg and logic. Let me go with the next one. So we are going to see about in this slide the logic and bit. What is the difference between these two? So this is a general very common question because logic has a 4-state variable. It has 4-state 0 logic 0 1 unknown value of x and the high impedance z. Byte are bits. All both are like 2-state values, which is 0 and 1. It has only logic 0 and logic 1. So in case of conversion, suppose we are converting a 4-state value into 2-state value like logic into bit or bytes, how it will be? The 4-state converted into 2-state, it will drive only logic 0 or logic 1. It cannot drive the high z and x. In case of high z, high impedance and x, it will be converted as a 0. So how synthesis will treat the 4-state variable, 4-state values as well as the 2-state values? Synthesis will treat 4-state and 2-state in the same way. There's no difference in terms of synthesis. So that's a very common thing that most of us not aware of it, but it treat both logic and bit byte in the same way. Usage logic, because 4-state variable, when we have the high level system modeling like RTL modeling, 0 1 is good enough. But when we have the multi port in out ports, multiple driver modeling is required. Analog modeling and GLS modeling, those modelings require like x and high z to be modeled. In that case we can use logic as a data types. So bit and byte, like I mentioned, it is used mainly for the high level where only zeros and ones are good enough. When the data when the data is getting corrupted, and then seeing that is getting recovered or not, so those modeling is not possible when we use bit and byte. Okay, reg and wire. So reg is 4 value. Each bit has a 4 values, 0 1 x and z. We saw on the previous slides. Wire has 120 values for each bit. It has a 4-state logic like 0 1 x and high z. On top of that, it has a multi-strength level of the signal. Like a signal can be defined as a multiple different strength of the signal swing or voltage that can be driven with the different values, strength values, by using the wire logic. That's the advantage of wire. So it's mainly used for the analog modeling. um, and like reg can be driven in the procedural assignment statement, like inside the always and initial, but it cannot be with the continuous assignment statement, like assign inside the assign block. Reg cannot be used. Wire is because it doesn't store any value. It's not like a register that stores the value. It is like only like continuous assignment is what works for the wire. So any times when it defines a wire, it can be used only inside the assign statement, assign block, as a continuous assignment, because it cannot store the value. So that's the main difference between the reg and wire. Okay, how about the logic and wire? This is similar to the reg and wire. The logic and wire is almost like similar, except that the multi-driver one, where we see that logic doesn't support the multi-driver. It doesn't drive the X, but reg would drive the X. Wire would be used to drive the X because it can support the all the 4 state, plus it also has a different drive strength. So wire data type is normally help to drive the X during the multi-driver. That's the one main difference between the logic and wire. The rest of things we already seen. The logic is a system Verilog data type, wire is a Verilog data type. That's additional points I add here. Other than that, I think we already know the rest of things. Logic only used to be can be driven in both procedural and assignment block, but wire can be used only inside the assignment block. So that's another main difference. Let me skip to the next one. Bit and byte, I think this is very basic of logic design. Bits are like it's a, both are two state values, zeros and ones. Bit is a 1-bit state integer. Byte is a 8-bit. Byte means it's a 8-bit state integer. That's the main difference between the bit and byte. That's all about this video. Thank you.